Now let us look at the next problem. A circular wire loop of radius r is placed in the xy plane centered at origin O. A square loop of side A, where A is given as much lesser in comparison to capital R, having two turns, so this has got two turns, is placed at its center at z equal to root 3r. So this distance is root 3r along the axis of the circular wire loop as shown in the figure. The plane of the square loop makes an angle of 45 degree with respect to the z-axis, which implies that the normal to the plane of the loop is also at an angle of 45 degree with the z-axis. Now, if the mutual inductance between the loops is given by mu naught a square upon 2 to the power p by 2 r, then the value of p is. So this is a very simple problem. Because of the passage of current in the lower loop, let us say the current is I, at a point inside the loop of side A. So this point A, this point in the square loop is at a distance of root 3r along the axis. So magnetic field along the axis is given by mu naught I r square upon 2 times r square plus z square to the power 3 by 2. So in this case, the magnetic field B will be given by mu naught current I r square upon 2 times r square plus root 3 whole square, that is 3r square to the power 3 by 2, which can be written as mu naught I times r square. So this becomes 4r square. So we can take 4r square to the power 3 by 2 can be written as mu naught I r square upon 2 times 8r cube. Okay, so the final value of magnetic field on the axis at a distance root 3r will be given by mu naught I upon 16r. Now since it is given that the value of A is much lesser in comparison to the radius r, that means we can assume that the magnetic field values will not be much different in magnitude at each and every point through the loop, and all of them will be parallel to each other. So the area vector will be making, the area vector n will be making an angle of 45 degree with the magnetic field. Now if we find out the flux through the square loop, so that will be given by NBA cos phi or theta. In this case the value of phi is 45 degree. So the value of n is 2 loops are there. The value of B is mu naught I upon 16 r, area is a square, and cos phi is 1 by root 2. Okay, now what we get is mu naught I a square divided by this will become 8, so this is 2 to the power 3 plus half into r. So this can be written as mu naught I a square upon 2 to the power 9 r, 9 by 2 r, sorry 7 by 2 r. So mu naught I a square upon 2 to the power 7 by 2 times r. Okay, so if we find out the mutual inductance, which is given by linked flux divided by current I. So we will get the value of mutual inductance as mu naught I A square upon 2 to the power 7 by 2 times R. So the value of P is 7. This is the correct answer.